Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be looking at ionic compounds, and then we're going to be looking at kind of the bare minimum of what ions are and how you name those ions. So the first thing we need to look at are what exactly are ionic compounds. So remember that cations are positive and anions are negative, and because they are opposites, they will attract to one another. And that's because, again, positive and negative attract. If you were to put two cations next to each other, they would actually repel each other. If you were to put two anions next to each other, they would repel each other. So the only way to get kind of that attraction is to put a positive and a negative in close proximity to one another. And that attraction between cations and anions is what we call an ionic bond. So when they get close enough to each other that they are stabilized, that means that they have kind of formed a unit now. And so instead of being individual things, they are now one thing. They formed an ionic bond, and now they're a compound. So again, ionic just means involving ions. So how do you get these ionic bonds to form? Well, metals and nonmetals are the key to everything. Remember, metals lose electrons, nonmetals gain electrons. So if you were to take this metal which is a sodium atom, and this nonmetal, which is a chlorine atom, and you were to put them in close proximity to one another, what would happen is this. The metal would lose an electron, the chlorine would gain an electron, and then you would form a sodium ion and a chloride ion. And when you put them together, you get, a salt crystal, basically. And that's kind of how ionic bonds work. One thing will gain, one thing will lose, and then when you put them together, they form these nice stabilized compounds. And they're very different from one another. Remember, sodium is like a very dangerous kind of metal that explodes. Chlorine is a toxic gas. But when you put them together, the reason why they're dangerous is because this one wants to desperately lose an electron, this one desperately wants to gain an electron. When they actually have done that, now they're totally, kind of normalized. And now you get, something that's useful, NaCl, sodium chloride, which is something that everybody needs in order to live. So what are the properties that ionic compounds tend to have? Well, the first one is that if you're looking at ionic compounds, they tend to have very high melting points. They also tend to have extremely high boiling points. Another little fact, they dissolve pretty easily in water. So even though they have these high melting points and boiling points, if you were to try to keep these things up, they wouldn't really melt. If you add a drop of water to them, these bonds start to break apart. They also conduct electricity pretty well. They tend to be solids at room temperature, and they also tend to form these nice organized patterns or crystals. So where we're going to end is not really getting into how you name ionic compounds, but we're just going to go into how to name ions. So how do you name different ions? The first thing you need to be aware of are that all metals form cations, like I just said. And when you're naming them, all you do is you add the word ion to the end. What you do need, though, is you need to know the charge from the periodic table. So here's a periodic table, and here's the pattern. So it's called the 1, 2, 3, 4, 3, 2, 1 rule. So this column forms +1 ions. This column forms +2. We skip transition metals. This forms +3. Now we start to get into the more negative territory. This is plus or -4, -3, -2, -1. And remember, noble gases don't have charges to them. So sodium is Na, we know that. But if I said a sodium ion, I don't mean Na, I mean Na+. And that plus is because it's a cation, and a 1 is understood if there's nothing after it. So that would actually be, sodium, but it's +1, and so that would form a sodium ion. What about magnesium? Magnesium's right here. That means it would be Mg2+, because it's in column 2. Potassium, right here, K+. Aluminum's right here. That would be aluminum 3+ right here, so Al3+. Now, because transition metals have a variety of different charges, that's why we skipped them, you actually have to tell me what the charge is in Roman numerals. So you'll see with these examples, right, it says iron, but then we have a Roman numeral 3 in parentheses, and that's because these guys, these transition metals, they have a variety of different charges. So if I said iron 3, I mean Fe 3+. Cobalt 2, that would be cobalt with a 2+. Palladium 4, palladium's right here, that would be 4+. Copper 1, copper's right here, that would be Cu+. Notice again, they're all cations, they're all metals, so they all have a positive charge. Now there are some transition metals that always have the same charge, so you don't even need Roman numerals for them, and those three that you have to kind of know are silver, always a +1, cadmium, always 2+, zinc, always 2+. There aren't any exceptions to those. Next, what about those nonmetals, right? So we've talked about everything here. What about these guys over there? Well, they form anions, and so those are negatively charged things. And instead of just saying, like, oh, the nitrogen ion, we actually change the ending of the element to "ide." So you actually, instead of nitrogen, you get nitride. Instead of oxygen, you get oxide. Instead of chlorine, you get chloride. And instead of sulfur, you get sulfide. So notice they all end in ides when they're negative here. And the negative things are only found on this side of the zigzag line. So what charge does chloride have? Well, remember, it's the 1, 2, 3, 4, 3, 2, 1 rule. So chlorine's right here. That means that it has a -1, and so you just put a little negative sign. That's chloride. If you had Cl without that negative, that would be chlorine, and that would be that toxic gas, remember? So what's next? Sulfide, that's right here, so that would be a 2-. Oxide, that would be a 2-. Nitride, that would be a 3-. So again, these guys right here, these are -3s, these are -2s, these are -1s. Notice there were no noble gases. And so there are some polyatomic ions, and poly means many, and those are ones that act as a unit. They're not found on the periodic table, and they're always going to be given to you, but here is our chart. It's either on the front of your formula page, and it's also in the notes, so feel free to take a look at it. There are a lot of patterns that you might notice in these, and that's totally cool and fine, but make sure that you know that, oh, if I see like ammonium, there's no like ammonium element on the periodic table. Or sulfate or hydroxide or peroxide or something like that. They're not found on the periodic table. And the last thing I want you to do is to make sure that you color code metals and hydrogen. These are all metals, remember. So they all form our positive ions. Nonmetals, these form our negative ions right here. And yeah, notice it says metal/hydrogen. Hydrogen is almost always going to be, in the situations that we look at, a positive thing. So it's going to be a cation. And then the metalloids, you won't really see those in compounds, but I want you to remember what the metalloids are. And that's it. So if you have any questions, let me know.